Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate Now let's look over here. In this example, the b is 1/2. So you're probably already trying to make some predictions here. Over here was a horizontal compress, because b was 2, which is greater than 1. Over here, you're probably figuring out, okay, if this is a half, this is less than 1 but more than 0, it's probably going to do the opposite of this, which is a stretch. So it's going to be stretched out farther. So let's do some values. Again, let's start with pi over 2, and then we'll look for patterns and adjust our table as needed. Okay, so you're doing 1/2 times pi over 2, which means you're really doing cosine of pi over 4. Ooh. Well, pi over 4, cosine, that's root 2 over 2. Alright, so that's going to have to be an approximation. We'll come back to that. Let's see if we can find some easier values to graph. What if we do pi? That's 1/2 times pi, so that's the cosine of pi over 2. Oh, that's 0. Well, we got that. Okay, so pi is 0. Okay. Let's try 2 pi. That's the cosine of pi, which is -1. Okay, so that's down here. Let's try 3 pi. Looks like the pi's, the whole number pi's, is what we want to do here. Look at your unit circle. The cosine of 3 pi over 2 is 0. So that means at 3 pi, it's 0. Oh, there it is. Okay. So let's go back this way, because look, we haven't even completed one cycle of this. So let's do 0, and then let's do -pi, -2 pi, -3 pi. In order to calculate this is the cosine of -pi over 2. The angle's negative. Don't panic. What it means is you're going to start in the same spot as your unit circle, but instead of going counterclockwise pi over 2, start in the same spot, but go clockwise pi over 2. So you're going to be down here at the bottom of the unit circle. So that is 0. Alright, so the -2 simplifies with the 2, so it's -pi. So now negative just means you're going to go in the clockwise direction. So the cosine of -pi is -1. And I'm going to guess at -3 pi, based on the pattern here, it's probably going to be 0 again. Alright, so -3 pi over 2, so you're going to start at the same spot. You're going to go 1 pi over 2, 2 pi over 2, 3 pi over 2. So the cosine up top is 0, like we suspected. Alright, now I have some patterns, so now I'm going to do some sketching. Now, look at that green graph. That's really stretched, isn't it? So this is a horizontal stretch by, what's the reciprocal? 2. Now you might be thinking, wait, but how do I know that, Stevenson? Well, let's check. Remember, the period for the regular sine is 2 pi. So let's look at this green graph. When does it finally repeat? Well, if I start here at -pi, I go above, down, and back. Now I'm hit 3 pi. So what's that total distance? Don't worry about the negative. This is 3 pi's, that's 1 pi. Together that makes 4 pi's. So if the parent graph has a period of 2 pi, 2 times 2 is 4 pi. So that's why it's horizontally stretched by 2.